Find the magnitude of the force on each segment of the wire as shown in figure if a magnetic field of 0.30 Tesla is applied parallel to AB and DE. Take the value of current flowing in the wire as 1 ampere. So this is the figure, okay? And this figure or diagram is made of current carrying segments or conductor. So we have segment AB of length 5 centimeter and carrying current I equals 1 ampere from end A to B. And next we have segment BC of length 8 centimeter carrying current I equals 1 ampere from B to C. And next we have segments CD of length 10 centimeter carrying current I equals 1 ampere from C to D. And we have segment DE of length 10 centimeter carrying current I equals 1 ampere from D to E. And we find AB, okay? We can see we find AB is parallel to DE. Clear? So we can see this from figure. And from question, okay, magnetic field of 0.30 Tesla is applied parallel to AB and DE. So we have magnetic field, okay, in magnitude B equals 0.30 Tesla, and magnetic field is parallel to the segment AB and DE. Now, in order to find the magnitude of the force on each segment, we use the concept of force experienced by current carrying conductor in the presence of magnetic field. So I'm writing over here, okay? We use this concept, okay? Force experienced by current carrying conductor in the presence of magnetic field is force F equals current element cross, okay, this is the cross product, and we have vector B. So the cross product of current element with magnetic field gives the expression for the force experienced by current carrying conductor in the presence of magnetic field. So we have this. So we are going to use this expression or concept for each current element carrying current in the presence of magnetic field, okay? So we have this. So I'm writing, okay, for segment AB. So what we find, okay, we find this. So we have current I equals 1 ampere, and we find magnetic field, okay, we can see in the figure, okay, we find magnetic field and segment AB are parallel. So in this case, okay, the force experienced by segment AB equals I. So I'm simply representing, okay, vector L by vector AB, okay. So I'm writing in this way. Clear? Cross magnetic field. So we have this. Now what we find? Angle between vector AB and magnetic field, okay, angle is 0 degree. So I can write in this way, okay, FAB equals I times AB in magnitude, that is length of segment AB, and we have magnetic field B and sine 0 degree, okay, because angle, so I'm writing over here, theta equals 0 degree. Okay, in this case. So we have this. Therefore, we can write FAB equals 0. So segment AB experience no force. So I can write in this way, okay? Segment AB experiences no force. Now, in same way, okay, for segment, okay, for segment DE, what we find, okay, for segment DE, we find this, okay. So as I said earlier, we are going to use this concept. So we have vector L equals, we can write in this way, vector DE for segment DE, okay. So force experienced by segment DE in the presence of magnetic field B, okay. This equals I, we have vector DE, okay, cross, so we have cross product, okay, and we have magnetic field, okay, and we can write in this way, this equals I, magnitude of DE, we have magnetic field, and sine 0 degree, because we know segment DE and magnetic field, okay, are parallel to each other. Therefore, force on DE equals 0. So segment DE, okay, so we can write segment DE experiences no force. So we have this. Okay. Now we are going to find force on segment BC and CD. Okay. So I have drawn this figure earlier. Okay. Now force on segment BC. Okay. So we have this, and for BC we have vector L equals, let us write in this way, okay, vector BC. Therefore, force on segment BC equals I, and we have vector BC cross product, okay, and we have magnetic field. So we have this. So in magnitude we can write I times BC, and we have magnetic field B, okay, and we can see angle between BC and magnetic field, okay, this angle is 90 degree. So we have this, okay, 90 degree. Therefore we can write sine 90 degree, okay. So this is 1. Therefore we can write force on segment BC equals current times length of segment BC times magnetic field. Now let's put the value, okay. So we can write force on BC equals current, and we know current is 1 ampere, okay, and magnetic field is 0.30 Tesla. So we have this, current is 1 ampere. We have 1 ampere current flowing through each segment, okay. We have this. Therefore, we have current 1 ampere, and BC is 8 centimeter in length. So we can write in this way in SI system, okay. So we have BC equals 8 centimeter. So we can write in this way, okay, in SI system. And magnetic field, okay, magnetic field is 0.30. Okay, it is 0.30 Tesla. So we have 0.30. So let us find, okay, this expression for force. Okay, so we have 8 is minus 2. So we have this, okay, force on segment BC in magnitude. Okay, this is 0.024 Newton. So this is force, okay, on segment BC in magnitude. Okay, so we need to note this. Okay, now we are going to find expression for force on segment CD. And for segment CD, we find, okay, from figure, vector L equals, or we can write in this way, okay, vector CD, okay, we can write in this way. Therefore, force on segment CD equals current and vector CD cross or cross product, and we have magnetic field. Okay, so in magnitude we can write FCD equals I times length CD, and we have magnetic field, and we have sine theta. Okay, so we need to find angle between magnetic field, okay, and segment CD. So what we see, okay, this angle is 90. Okay, this is 90 degree. Clear? So this angle, we need to find this angle. Okay, so in this triangle, we find this angle equals, in this triangle, what we find? 90 plus 60, and let's call this angle as X. X equals 180 degree. Therefore, we find X equals 90 minus 60 equals 30 degree. So this angle is 30 degree. Okay, so we have this. So if this is 30, so I'm writing over here, X equals 30. Okay, then this angle is also 30 degree. So we have this. Clear? So this angle is 30 degree. Therefore, angle between magnetic field and CD. Okay, so we have this. This is CD, and we have magnetic field. We have magnetic field, and this angle is 30 degree. So this angle is also, or this angle is 30 degree, and this angle is also 30 degree. So we have this. Okay. So what we find in this case, okay, FCD equals I is 1 ampere. Okay, and length of CD is 10 centimeter. So 10. So I'm writing in SI system. Okay, and magnetic field is 0.30 Tesla, and we have sine 30 degree. Okay, now let's find this value. Okay, So force on segment CD in magnitude is 0.015 Newton. So we have this.